not doing my best on What's the difference between a sequence and a series? A series goes on forever. Couldn't a sequence go on forever? Potentially. What do you think? A series is part of a sequence?
Adding the terms of
Yeah, sequence. Or series is when you add the terms of a sequence. Let's see. So for example, if something is, give me an example of an arithmetic sequence. Sequence, this is, okay, that's kind of boring, but all right. We could be a little bit more creative, I would hope.
Yes.
It's a sequence, yes. It's arithmetic, yes. That is a sequence, yeah. All right, can I add, what if I said 1 plus 2 plus 3? You don't need a calculator for this. It's still arithmetic, yeah? It's still arithmetic. Each term you're adding 1, but now I can add them together and I can get 3 plus 12, 15? Is it 15?
Yeah.
Okay, well that's super boring. Give me a better sequence, please. Not convenient, icky sequences. 3, 6, 9, that's boring too. 3 plus 3 plus 3 plus 3. If you're going to do 3, 6, 9, at least start with like 12, 15, 18.
90.
I heard 6, 18. What's the next one? Oh, that's geometric.
30.
It's good that you look at your notes. What is it, Kevin? If I want it to be arithmetic, the next term needs to be 30, 42, 54. Let's just stop there. That's a sequence. It's a terminating sequence. It's a sequence. It's a pattern. It's a list of numbers that follow a pattern. How do I turn that into a series? We already know the pattern. What do I do to turn it into a series? Add them all together. And you can simplify that. I'll let you use your calculator. Maybe. $24, $54, $96, $150? Yes.
Mental math.
That's right, mental math. No, it's a series.
No.
No, I terminated it. You can't add it. This is a really good point. If there's a ... the ellipses, meaning the sequence is going on forever, how do you add a sequence that doesn't terminate?
So that much.
No, I was just showing that was an example of a sequence. Sure.
Okay.
Okay, so what if I wanted you to add, I told you to use your calculator, I don't want you to use your calculator. Okay, I'll let you use your calculator. How about, no, that's boring. I keep coming up with these boring sequences. Let's try something better. How about, that's not arithmetic or geometric. Tyler said, what'd you say, Tyler? Oh, that is arithmetic. That is arithmetic. Great, okay, we'll go with this one. Okay, so this right here is an infinite sequence. It's an infinite sequence. It's got the dot, 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 dots. It goes on forever. Yes? Okay, so what's going to happen if this goes on forever? What's it going to add up to? This is a great question. Negative infinity. This is going to add up to negative infinity because of the ellipses. It goes on forever. But I'm going to end it. And I'm just going to do it up here so I have more room. Please tell me if I make a mistake. It is now a series. It is now a series. Oh, Miss Babby, I guess on addition. Yeah, it is. You're adding the opposite. Everything can be looked at as addition. I want you to evaluate this series. Negative 150, I think. I think it's negative 150.
Yes, it is.
Is it?
Yes.
Alex, you just went in your calculator? Okay. I'm not that good at mental math. I'm really not. But I knew the shortcut to figure out that it was negative 150. First of all, the answer has to be negative, right? You're approaching the negative direction. Negative plus a negative plus a negative plus a negative plus a negative. My answer needs to be negative. Agreed? Okay. Figure out why the answer is negative 150 without using your calculator. Talk to your neighbor. That's why you have a neighbor. Oh, you don't have a neighbor. Some of you remember, I can hear you remember from last year. It's great. S to then, T to then, A to then. What do you got for me? Yes, Kaveen.
It's just negative 30 times 5.
Where'd you get negative 30 and where'd you get 5?
There's big difference. Negative 13 minus 17 is negative 30.
Negative 13 minus 17?
Negative 30. The two middle terms is negative 30.
How do you know those are the middle? What if it's an odd number of terms?
Well, I didn't think of that.
So, Kaveen said, well, what do you do, 13 and 17?
Yeah.
So, Kaveen said negative 13 and negative 17, hold on, Brian, is negative 30. Agreed? But he said add that 5 times, and I'm confused where the 5 comes from.
Well, it's just, that's negative 30, and then if you keep going out, negative 9 and negative 21 is also.
What do you mean going out? I know what he means, but like explain that. There's no such thing as we're going out.
You move one term to the right.
One term to the right and one term to the left.
Yeah.
Okay, we'll do a demonstration of that. Ryan?
I choose the outside terms or outside numbers, and then you still get negative 30. And there are 10 terms in total, so you just divide that by 2.
Okay, so Brian's saying the same thing Kaveen is. The difference is Kaveen and Corey started in the middle, and Brian started on the outside. What? Three and negative 33. How much? Negative 30. Negative 1, negative 29. How much? Negative 30. Negative 5, negative 25. Wow, you see a pattern?
Yes.
Negative 9, negative 21.
Negative 30.
Negative 30, negative 13, negative. How many negative 30s are there? 5. How many terms were there altogether that I gave you? But we only have 5 sums. There were 10 terms, boo, 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 boo. And we have 5 negative 30s. Why aren't there 10 negative 30s? Yeah, sir.
Each pair of terms is negative.
Each pair of 2 terms make one sum. 2 terms make one sum, which is a total of 5 terms. So what was the answer to this? Negative 150?
Yeah.
What if you have an odd number of terms? Kavin's response was, I didn't think of that. There are sometimes an odd number of terms. Let's do the same exact series, but let's take off the negative 33. Let's do the same series, but let's take off the negative 33, and now there'll be an odd number of terms. The answer is not negative 150. Okay. You could find the sum by taking the negative 150 and adding 33 back in, but that's not the point. That won't do you any good if you don't know the whole series. What do you got?
You do Brian's way by adding 3 and multiplying it.
Okay, so Corey says we could do it Brian's way, but what was the last part you said?
But take the amount of terms and divide it by 2.
Take the number of terms and divide it by 2. How many terms are there?
9.
Divide that by 2, that's 4.5, right? How do you have 4.5 terms?
When you divide the average of the first term and the last term.
Or how do you have 4.5 terms? You don't. It's not 4.5 terms. It's 4.5 4.5 pairs or 4.5 sums. Yeah. Yeah, Alex.
The way I did it was, I don't know if you're allowed to do this, was I moved the 3 out of the way and just did the pairs all the way to the middle. And then you get negative 120, and then you just add the 3 back in, and you get negative 170.
No, you got to be careful with that because this is negative, 26?
Yeah.
Half of negative 26 is not 3. What happens if you took off the negative 29 and did the way you did? You get a different answer. Yeah, Brian?
Wait, can you just do like the sum of the outside terms multiplied by how many terms are divided by 2?
Yeah, that's what we were just saying.
Oh.
That's how I got 4.5. So, negative 26, blah, negative 26. But this is why it works.
Just add 13.
And what's half of negative 26? Negative 13. And that's where the half comes from. You have 4 sums and half of a sum left. Well, half of negative 26 is negative 13. So what's the answer to this?
Negative 170.
Negative 117?
Yeah.
Okay. So we did 4.5 times negative 26. Negative 117? Okay.
I just did 4 times negative 26 and then you just added.
Yeah, 13 back in. That's exactly what we just did. Okay, so what about something like, well, you know what? I want a generic formula, and we use S sub n for sum. It's very similar to summation notation, bless you. It's very similar to summation notation. Out looking in the book. Come up with the formula. You know where it comes from. There's no memorization necessary. How many sums? How many terms? Try.
Number of terms multiplied by
I think I got it with other.
What?
Alright, n divided by 2 times 1 3 T1 plus N. Sub, yeah.
That's what Nate came up with. Did you look in the book?
No, I'm smart.
What's N represent?
The
The number of terms. Number of terms. Oh, I just erased it. How many terms do we have? We had whatever it was. We had 9 terms, and we divided that by 2 because it takes 2 terms to make one sum. It takes 2 terms to make one sum. So you take the number of terms and you divide it by 2. Pair. 2 for a pair. Nate, where did T sub 1 plus T sub n come from?
Well, I was trying to think about how I can plug in negative 26 into it in the example, and it would be kind of weird to do like T2 plus like Tn or whatever. So I guess the easiest one would be T1 plus Tn.
Sub. Sub.
So, yeah.
You added 3 plus you added negative 29. Agreed? In the series, 3 is the first term. Correct? Negative 29 is the last term. Correct? Yes, no, maybe so? Okay, so once I add 3 and negative 29, first term, the last term. Keep shrinking down. Arithmetic series, there you go. You will be given no formula, so you need to know it. Let's do,
Where does it say it in the book?
it's in there somewhere, I don't know. Bean, where is it?
How would you say?
Because you had the book wide open and then you looked at me when I said don't look at the book.
Except that the sequence here is 2 divided, N divided by
583. It's on page 583 in case, there it is, in case you're wondering. Okay, so I want you to evaluate, I want you to find the sum of first 30 terms. How do I know it's the first term? You're always going to assume that it's starting with the first term, because if it's not starting with the first term, like if you're finding the sum of the second through the 31st term, whatever, it's a total pain. Where are we? Let me do, T sub 1 is 17. Yeah.
If you're starting from like the kth term to the nth term, can't you just do S sub n minus S sub k plus 1?
If you're doing the kth term,
Sum of the kth.
so you want to do the sum of the k terms. What do you want to do?
From like, so like if you're doing from like the 3rd to the 30th term, could you just do the sum of the 30 terms minus the sum of 2 terms?
Yeah, sure, but why would you want to do that? Yes,
I would.
that is exactly right. Okay, so here's the problem. We have our formula. So S sub 30, N is 30 over 2, agreed? Plugging in, which means I'm going to have 15 sums. Boom, boom, create a sum. Boom, boom, create a sum. Boom, boom, create a sum. The first term is what? Oh my God, niece. Drink some water. The first term is what? 17. Plus the last term.
30 times 10 plus 7.
Close. The last term in this particular series is the 30th term. Agreed? The last term in this series is the 30th term. Do you agree with that? Okay, so find the 30th term. And then there's an alternative formula, which I don't use, but I'll show you on the board what it is. So the 30th term is equal to the first term plus d times n minus 1. That's the formula from whatever, last week. Arithmetic, t sub n is t sub 1 plus d n minus 1. What's the 30th term? 17 plus 207? 307?
Yes. 307 because it's 29. Because 30 minus 1.
Oh, 290. 307. Great. Yeah. So this is 15 times 17 plus. This is why you will be allowed your calculator. 324 times 15 on the first clue. 4,860? Thank you. So there's an alternative. What if you don't know the nth term? I didn't give you the nth term. I gave you the first term. I gave you D. So alternatively, what's T sub n? Brian, you have a question?
Like, just substitute the T sub n for.
That's what I'm doing. I just do it. I guess what I do is a longer plug-in, but I don't like to memorize anything extra. So what's T sub n?
T sub 1 plus
T sub 1 plus what?
Times.
Combined like terms. So this is an additional formula. I do not use it. It certainly works. I just kind of plug in as I'm going along. Nate, what are you saying?
That's what's looked in the book when I looked at.
Okay, so I don't, but whatever, it's fine. Prefer whatever. Okay, let's do a summation with summation notation. Let's do a summation notation. Remember your funky sigmas? Let's do.
What's the K equals 1 on the bottom again?
Say it again.
What's the K equals 1?
That tells you your starting term. You're starting with term 1.
Is the other K?
Sometimes, but not really for what we need. Write it down. You'll remember it quicker, I think. You'll commit it to memory, whatever. What's N?
70.
70. I'm adding 70 terms, which is 35 sums. 70 terms, but each pair makes a sum. So I'm doing 35 sums. So what's the first term?
1. 4, 5.
4. Plug in 1. 1 minus 1 is 0. 3 times 0 is 0. Plus 4 is 4. Okay, the nth term in this case is the 70th term. So plug in 70, I don't know. 3 times 69 plus 4. How much?
211.
Surround says 211. Do we believe him?
Sure.
Okay.
Yes.
4, I plugged in 1 to get the first term. 211, I plugged in 70 to get the last term because they told me to add 70 terms. That's where the 70 came from. I don't know. 35 times 215 is not happening.
7,525.
7,500 what?
25.
Not 25, need 25. Yeah? Arithmetic. Not everything's arithmetic.
Wait, Miss Schneider, wait,
What?
K1 if it isn't T1?
K sub.
K.
This is just telling you the first term number. Fine, so instead of T, I should have used K. Instead of T, I should have used K.
Where did 4 come from?
I plugged in 1. The first term. So I plugged in 1. I got 4. Where's the 70th term? I plugged in 70. You plugged in 70 and told me it was 211. So this should be K. Just variables. They're just variables. All right, geometric. When we're done at the end of notes, we'll go through and write down the formulas because there are a lot for this section, or this chapter. How many we've done? 4 already? 5, something like that?
7.
Give me a geometric sequence. Oh, you started to. Tyler, you gave me one. Do you remember what it was? If you don't remember, that's okay. What was it? 3?
-1, -5, -9.
Oh, that's arithmetic.
Yes.
Yeah.
That's what you gave me. My apologies. I wanted geometric.
The one that Corey was given. It was Corey.
Oh,
It was
sorry.
like
Corey, what were you?
18, 14. Oh,
6, 18. Yes, I remember this now. 54, 108. Let's do a couple more.
54 times 3 is it's
54 times 3 is not 108.
162.
It's 162. Just kidding. See, I can make mistakes. That's why you guys are here.
That's the sole reason.
What's that?
That's the sole reason we're here.
A solid reason?
The sole.
Oh yeah, that's the only
only
reason why I
reason
make
we're here.
mistakes. It's all of my mistakes are intentional. Every single one of them.
For educational purposes.
for educational.
I'm kidding. I make mistakes all the time. So do you. It's part of life. You don't learn if you don't make mistakes. That's just my excuse. My excuse is it's a learning experience when really I just make mistakes. A lot of them. All right. It is geometric. It's terminating. There's no ellipses. There's no dot, 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 dot. What would the sum be? What would the sum be if there were the da-da-da-da-da going on? Infinity. It's exactly right. So if it was 6 plus 18 plus 54 plus blah, 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 it's infinite. Okay? Find the sum. Right now it is a sequence. To turn this into a series, this is a straight plug and chug. Plug and chug. I don't know why I started saying that. I just did.
That's pretty crazy.
Because that's what you do. Or how fast.
Do we agree with that? So let's try and figure it out the same way we did with arithmetic. Let's try and figure it out the same way with the arithmetic. We're like, the last terms, da-da-da-da. See if you can figure that out. Without cheating in the book. That's why I know you're guilty. Because I say no book and you put your hands up. True guilt.
Most schools force me.
Oh my lord.
I'm so hostile.
Try.
No, nobody.
That's something to do.
Try without looking in the book. You have to expand. Stop cheating.
You have to respect.
Okay, a big break.
What's wrong? Okay, I'll give you a hint. You're probably not going to be able to come up with it on your own. So it's one of those, you know how I feel about memorizing, but this is like sum and difference of cubes. You have to memorize sum and difference of cubes because that's just how it is. Plus, minus, plus, minus, plus, plus. You're just going to have to memorize for geometric. It's not confusing. Well, it's just one of those deals you have to memorize. So this is for geometric. And there's probably some great, memorize it, whatever, but Okay, T sub 1. Everything starts with the first term. I mean, everything we've done in all of these series, sequences, have all started with the first term. Geometric. R for geometric, not D. R for geometric. R. It's going to have a log. You can never get away from logs. You will not have to use logs when you stop taking math classes.
I really forgot.
You may want to.
Wait, Michelle, what did you say?
I love log.
Me too. I love logs.
Oh yeah, log is one of the things that matters. Because you ask like.
Right, yeah.
Log is log.
In addition.
What's that?
I love addition.
Kevin says he loves addition. That's awesome.
Who doesn't?
Oh, that's so funny. Okay, well, you know what? Unfortunately for you, Kevin, there's more to life than just addition. Although that's not really true, because subtraction is just adding negatives, and multiplication is just repeated addition. So actually, addition can get you pretty far. But I think it's not going to help you like graph a parabola.
I like
Just count it. Just count. Okay, so here's what I want to do.
Addition more and not even.
That is true.
What do you do?
Use addition more right than logs. In life,
You
have
use
to add.
that's not true. That is not necessarily true.
I got shopping.
I use logs just as much as I use addition.
But you're a math.
But you may be a math teacher someday.
I will not be a math.
You know
I
what? That's
doubt
what I
it.
said. I said that until I was a senior in college. But no, sophomore in college, I was like, I'm not going to be a math teacher.
I'm 105% sure I'm not going to be a math.
You can't be a math teacher if you think there's 105%.
Oh,
That was a good one. All right, here we go. Let's practice. A lot of this is utilizing your calculator properly. So, how many things did we add, or how many terms? 1, 2, 3, 4, 5, 6. We used 6 terms. Okay. So, the sum of the 6 terms. You must practice using your calculator. If you know the formula, but you don't know where to use parentheses properly, you're going to have a hard time. What's the first term? 6 in the same series that we just did. Want to practice to make sure we get 2,184. 1 minus, what's R? 3. What's N?
6.
Okay. Over. 1 minus 3. Okay, so time out. 1 minus 3. Whoa, time out. 1 minus 3 to the 6th is a negative number. Agreed? 1 minus 3 is a negative number. Agreed? A negative divided by a negative is a positive. Hence, my sum needs to be positive. So this is how you can tell sometimes I got a negative answer that can't possibly be right or whatever. Go for it.
Wait, Miss Bethany, but isn't there a good thing like if it's like minus 3 and like square it, like positive?
So that's not what I'm doing because of the parentheses.
So how if it would be negative all the time if it was outside the
Correct. Correct.
But if it's inside, it's
Then it's positive. Well, no. If it's inside, then it depends. If the exponent is odd, then the answer is negative. If the exponent's even, then the answer is positive.
It works.
You should get 2,184. If you're not getting that, try again. Ask your neighbor, but you have to try it. I'm gonna be honest. I'm not gonna help you with the calculator on quizzes, tests, finals, whatever. You have to know how to utilize.
Oh.
2184.
Yes.
Yes. All right. Okay, so we're just going to do a couple more examples with funky logs and quadratic formula, blah, blah. So let's find the sum of the 34 terms. So n's 34. Given t sub 1 is 7. This is a problem in the book. I shouldn't do this one. Oh well. Oh. Do it again so I
I
can
always
see.
forget.
All right. This is literally not a straight plug-in chart. Or is it?
Yeah.
Yeah, you don't need to know the 34th term.
Yeah.
You don't need to know the 34th term. You need to know the first term. You need to know R, which I gave you. And you need to know N, which I gave you.
Oh my god, that's true. Keep object.
You do it, and then I'll. You're not using parentheses properly.
Oh, this is not
Where is it?
Oh,
2,184. I wouldn't use all those parentheses. Like when I do it, I do 1 minus 3 to the 6, get an answer. And I do divided by -2, get an answer, and then time. That's how I do it. A lot of students do what you do, parentheses. I always mess up the parentheses. Works either way.
Not a fraction, right?
You can't do a math frac on this one, I don't think.
No.
Is math frac available? So how do you know decimal fraction? Follow the format of the problem. Follow the format of the problem. You were given a decimal. It's okay to give me a decimal in return. What do we got here? What's the first term? Is it big? Is it big? It's modest.
Moderate. 53.63.
I did it right.
Definitely.
Wait, what did you get?
I got 404.1, give or take. No?
Yes.
34 in front of.
No, the first term. Oh, you mean that? So the first term is 7, 1 minus R, 1.03 to the n over 1.03. Perfect.
I don't know.
All right, let's do what's wrong. Am I doing something wrong? Because I think I have it right.
Yeah, I got it right. I got
What was it? 411 point.
404.11. It's like an error.
Also, we just round it,
Yeah,
but
no
we
error 404.
Do 1 minus 1.03 to 34th.
I use parentheses.
I don't use parentheses. I just do 1 minus 1.03 to 34th. Get an answer. Divided by, here you're going to have to use parentheses. 1 minus 1.03. Get an answer. Times 7. Michelle?
So if you can't put in the fractions, you just round to the.
I usually tell you how to round.
Oh.
I think almost all the time I think I tell you. Generally 100th, but if I don't tell you how, then you just round properly. 4.04, whatever it is. Yeah, Nate.
Wait, so first what you would do is on a negative 1.03 to the power 54.
No. This is 1.03 to the 34th,
Okay.
and then
so,
1 minus that answer.
So it's always negative.
In this case, yes,
Okay.
because you're subtracting negative, adding the opposite, adding a negative.
One
Yes, Tyler.
How would you do the math fact?
It doesn't work.
Oh. But like, how would you do it in any other problem?
It's math frac, and if it gives you a decimal, that means it's not possible to be written as a fraction. Okay, let's do one with logs, and let's do one with not logs. The sum is given. Absolutely. Absolutely. All right, we're gonna do 2 more. One arithmetic and one geometric, and I hope I'm gonna find a log somewhere in there. Oh, Portia, she fell off.
Where is Portia?
Portia retired.
What?
Portia retired. She's allowed. She had enough of me.
Oh, I thought
She's been coming to school for 4 years. Oh, not retired, she died. Retired like No, she retired as in she's home laying on the couch all day. That's what she does. Not that she did anything different here though. Okay. I know, me too. I totally wish I could do that.
Are you gonna get another dog?
I hope so, but it's a long process. I can't just get a dog and, the dog just shows up at school one day. There is training involved. There's finding the right dog. I have a lot of,
And why?
what's the word, not restrictions. I have a lot of,
Allergies?
no, what's the word? Requirements. I have a lot of requirements. I'm sure that comes as a huge shock to you, but I have a lot of requirements.
Really?
So basically,
Why did it?
Arithmetic or geometric?
Arithmetic.
Arithmetic. How do you know it's arithmetic?
Because it's D.
D. Okay, so here's my suggestion to you. The sum of n terms is n over 2 t sub 1 plus t sub n. Or a. Like the trig book uses a all the time. Why do they use different letters? It doesn't matter. It's a variable. Why do we use m, x, and b? They're just variables. I know some things. I'm missing some other things. What do I know?
You know what? S7.
I know S sub n, sub, Sn. That's like something on your chemistry periodic table of elements. Is there an Sn? There is. See, Sn, what is it? Tin?
Yeah.
Okay, so we're not talking about tin. We're talking about, thank God we're not talking about that stuff. I don't know how you guys do chemistry. What's N? Don't know. What's the first term? Perfect. 'Cause I don't know N, right? They're asking me to find it. Okay, if I don't know N, how do I know the nth term?
You don't.
I don't,
You have to find it.
but I can find it. And I can use something besides addition to do it.
Yes. Subtract.
The nth term is the first term plus d times n minus 1. Where'd I get that from? Those are the general formulas that you just need to know. All right, so plus the nth term, the nth term, the nth term, the nth term, the nth term. First term is 8 plus d is 5 and minus 1. Okay, and now it's algebra. Now it is algebra.
I like it, bro.
You have a little bit of adding in there.
Some adding in there.
Algebra.
Okay, I'm gonna do 2 steps at once because I know we're capable. Multiply both sides by 2. What's 4859 times 2?
9,780.
Okay, so 11 plus 5.
9,718, Mateo?
Yeah.
Eight plus 8, 16. Minus 5, 11.
Yeah.
Plus 5n. I distributed in my head.
Oh.
Plus old news.
Factoring.
Nope. Iterated is factor. Quadratic formula. It's a quadratic. Distribute.
Oh,
Is a
this
quadratic.
again.
How many answers are you going to get? 2. You're going to get 2 answers. The degree is 2, but 2 answers can't work. I want to know the nth. I want to know how many terms am I adding. I can only be adding a certain number of terms. So chances are you're going to get a negative, which can't work. You're going to get a decimal, which can't work. You're going to get 2 answers, but one of them cannot work. Go. Quadratic formula. You definitely need your calculator. One of them's a nice number. Yeah, Michelle? One of them's nice.
Wait, what's C?
What?
What's C?
Set it equals 0. I'm going to do it. I'm going to do a. Oh, yes. We're going to do a geometric after this. And then I'm done yammering for at least a few minutes. Maybe. You need a whole number. If you get a decimal, you made a mistake. If one of your answers is not a positive whole number, you made a mistake. Oh.
It wasn't going to be negative.
It's perfect, 43. Again. Set it equal to 0 first. I skipped that step. We have to be able to skip steps, you guys. It's a quadratic formula, you know that. So you get an answer, I don't know what it is. You get an answer that doesn't work, and then you also get 43. So let's understand what you just found. The first term is 8. D is 5. Am I on the right track here? Yes, no, what?
Yes.
If I add the first term, the second term, if I add all the way up to the 43rd term, I will get 4,859. That's what you just found. Last one, geometric with logs. You better believe you're going to get one of these. Quiz, test, final exam, whatever. You have to know how to utilize logs. So if I'm a student, I'm putting a star next to it that says I better learn how to do this. So I'll go through this one a little bit more step by step. Formula, S sub n, T sub 1, Again, I think it's helpful if you write down the formulas. The more you write them down, the easier it is to remember them as you go.
How do you know it's going to involve logs?
Because I asked you to find n, and n is an exponent. You need logs when you have exponent variables. So find n. Plus, you'll realize it as we set up the problem. So we're going to say 6,817.748. What's the first term? 47. 1 minus, what's r? 1.06 to the n over 1 minus 1.06. Okay. Order of operations. This is not 1 minus 1.06 to the n power. It's 1 minus 1.06 to the n. Okay? Order of operations. All right, get started. No, we're good. Oh, yeah, for me. So divide both sides by 47. I'm going to store numbers in my calculator as we go. 6817.7 divided by 47. The numbers in my calculator, I'm just going to round it to put it on the board. Okay, the numbers in my calculator. So I divided by 47, and I got 145.06. But the number's in my calculator.
Alright, so
This is a number. I believe it's negative 0.06. Multiply both sides by negative 1.06. Sorry, I lied. I'm going to multiply both sides by negative 0.06. And I'm now at negative 8.7 blah blah. You with me? I'm at negative 8.7 blah blah.
Why did you divide?
I didn't. I multiplied both because this is the denominator. So to get rid of the denominator, multiply both sides of these. Okay, so where am I at now? Negative blah blah is 1 minus 1. Negative 8.7. Some of you went ahead of me. Fantastic. Subtract 1 from both sides. Divide both sides by negative 1. Here are your logs. Up till here, it's really just a bunch of algebra. Dividing both sides, multiplying, etc. Multiplying, etc. What's the base? What's the base? Yeah, 1.06. So this is going to be the log base 1.06 of 9.7 equals 10. Hold on, subtract 1. You can do alpha window, number 5. And you get 39.000000106.
oh, nothing happened. It said error.
Made a mistake somewhere, you must have used a negative. So, it's 39. For all intents and purposes, it's 39. You cannot have a decimal, term number. Why is it not exactly 39? Because we started with an approximation. If you're getting a negative, if you are getting a ridiculous decimal, bless you. You made a mistake somewhere along the line.
So n equals 39, but it's got like a really small decimal.
That's what I just said. You started with a rounded number, so your answer is going to be, but if you notice, Nate, it's 39.00000, whatever. So for all intents and purposes, that's 39.
So you don't put the
No, because it's 30. It's the 39th term. It is not approximately the 39th term. It is the 39th term. Yeah?
Yep.
Okay. All right, in your seats, ready to go for 40.